Now, Bismillah ar-Rahman ar-Rahim. We're going to look at, we're going to continue our discussion on the design patterns. And just to quickly refresh our memory, on Sunday, we talked about what the design patterns are. And we said that there are three types of them, something called creational design pattern, structural design pattern, and behavioral design pattern. So uh, we were looking at the creational ones the other day. Remember, the creational design patterns focus on what? They focus on creating objects, right? So if you want to create objects and you want to create them in a certain way, then as a good design option, you have something called creational design patterns. And there are many of them. We had a look at the singleton the other day, right? Remember what was singleton doing?
It was making sure that we only make one instance of a
Exactly.
class.
So it was making sure that only you create one instance. Then we had a look at the factory one, and factory was on the flip side of the singleton, and the whole focus was to create multiple objects of something of some related classes. We started having a look at the abstract factory, so inshallah we're going to look at it again today, and then we'll also look at the prototype today, inshallah, right? Probably we'll leave the builder for Thursday. Any questions on singleton and factory before I talk about the abstract factory? Everybody seems to be happy, right? Okay. Now, the abstract factory, the concept is very simple concept. You know, this is the whole idea is that you want to create something called super factory, which will help you create other factories. So you want to create a super factory, which will be like, and that super factory will be called like a factory of factories, right? So whole idea is that you want to have, rather than having only one factory, which was happening in the factory design pattern, rather than have only one types of a factory, you can have now multiple types of factories, and then you'll create something new now as part of this design pattern, and it will be called super factory or what we call abstract factory. That's the whole idea behind it. And this abstract factory pattern allows you to create an interface, and that interface is basically going to do what? It's going to be responsible for creating a factory, first of all, of related objects without explicitly specifying their classes. So in other words, a group of classes who are going to be using these concrete classes, they don't need to really explicitly specify and they don't need to really know their details as such. We will segregate them, we will group them together in such a way that whoever wants to create an object of a certain type, he will just come to our abstract factory, and from the abstract factory he will be able to select the kind of object he wants by creating its own factory, and then just go on and generate multiple objects he wants to create. Does it make sense so far? Of course, we haven't seen an example here, but as a concept.
Yes, Doctor, it's clear.
Okay, thank you. Now, so I think I've shown you this example on Sunday as well, so we'll look at this one again. Basically, what we are doing here is that we have two kind of related things. Number one, we have something called shape, and then number two, we have something called color. So we have different kind of shapes with us, and we have different kind of colors with us, and eventually we want to draw these shapes and we want to fill them up somewhere here in our demo class. So one option is, without using this design pattern at all, or any of the abstract factory or factory design pattern, we basically go on from the main method of the demo class, go and create these objects individually, right? And but that's not a what we call a well-structured design, because you will be creating a lot of coupling and a lot of dependencies while by segregating the way you see in front of you now, you're basically structuring in such a way that you can make changes easily here. So first of all, this is the first thing we have. We have two kind of things we are trying to do for which we want to create objects. Then what we'll be doing is that we'll be creating their factories, right? And individually we'll be creating two factories. One will be for the shape, the other one will be for the color. And since they are factories, multiple factories, we'll be creating an abstract class called abstract factory, which will allow us to, get the, it will make sure that these factories have get shape and get color methods. And eventually we'll have something called factory producer, which will allow us to produce these factories, in this case shape or a color, and the main method will use it. Now, how exactly we do it in a piece of code, we'll just look at one by one and see what's happening here, right? But as a concept, again, the idea is you want to be able to create multiple factories so that, you can create multiple group of objects. So first of all, we'll be doing what? We'll be creating this shape interface, and next we will have these rectangles, squares, and circles, and these rectangles, squares, and circles basically just gonna go and implement this interface. So basically we are done with this part. We created an interface and we created these circles, squares, and rectangles which implemented it. So similarly, we're going to do exactly the same thing now for this part of the diagram. As part of the code, we will just go on and create a color interface and can implement red, green, and blue colors. So far so good, right? We haven't done much here. We're just in a very yes, please.
A non-abstract factory can only use one factory, right?
Non-abstract factory can only use one factory, which means basically if this was not an abstract factory design pattern.
Yeah, so we could only have either a shape or a color factory.
True, absolutely true, absolutely true. So if I'm using only one factory, or I only need to have one factory, then I'll be using something called factory design pattern, right? And then I don't need any of this abstract factory producer because I only have one factory. So the demo class or the classes which are using it will basically just be directly talking to this factory, and that's it. But this is we are going through this process because we need multiple factories now, right? Okay, we're done basically with these two parts. We're done with these two parts. We haven't done any. It's not that difficult. We just created these two different groups of classes and structured them together. Now, next, what we'll be doing, we'll be creating an abstract factory class. So basically, we go on and create an abstract class to get factories for color and shape objects. So basically, we create an abstract class called abstract factory, and it will allow us to create, color and get colors and shape and get shapes. Now, basically it will return, an object of color, and this will return an object of shape. Now, so basically we did this part as well. Now, since this is an abstract factory, these factories can go on and actually implement and give the meanings of what is the meaning of getting a shape or what's the meaning of getting a color. So that's exactly what will happen here. So take a moment to see what exactly is happening here before I go on and explain this one. So what we are doing here now, we have this shape factory, right? Which is extending the abstract factory class. And since abstract factory had two methods in it, the get shape, it had two abstract methods, get shape and get color. So basically we're forced to do that. We implement it. So get shape will do what? You tell him what kind of shape you're looking for. If you don't specify anything, you will get null. If you're saying I want a shape of circle, you will get a new circle object. If you're looking for a rectangle, it will tell you a new rectangle object. And if you're looking for a square, it will give you a new square object. Okay. And similarly, the same thing will happen for the color factory as well. That you'll be saying what kind of color you're looking for. It will get you the color object. So if it's looking for a red color, it will give you a red object. If you're looking for a green color, then it will give you a green object and a blue object. So far, so good.
Doctor,
Yes, please.
this is violating some of the design principle, right?
Exactly. Yes, good observation. I was waiting for this. I was gonna ask this anyway. Yes, go ahead, please. Go ahead.
Yes, but I don't remember its name. I think
Single responsibility, probably.
Yes, and also the one with the inheritance.
The Liskov substitution, huh?
Yes.
Absolutely,
Right.
absolutely. Now,
and even the open and closed.
even
principle.
open and close, because you're not supposed to go on and have these kind of,
Yes.
implementations, right? True, absolutely true, absolutely true. That's why I said that in the beginning, and I'll I was just waiting for if nobody would have commented, I would have asked this question as I did in the previous section. So Jazakumullah khair, I'm very happy actually. So basically, this is just a sample code, okay? And this is probably not an optimal way of implementing it. Okay. But this is a good example for us to abstractly understand and conceptually understand the concept of the abstract factory. Okay. So basically, if you look at this one, let me show you the diagram here. At the end of the day, basically what we want to do is we want to have these factories, and that's it. All right. Can we think of in a case, or maybe let me show you guys this class first, and then I'll ask this question: that can we get rid of this class? Do we really need this class, which is actually kind of violating our principles, right? So let's look at this this factory producer class. What exactly it's doing? So it's saying shape factory. If you want looking for a shape, get him a new shape factory. And if you're looking for a color, it will get you a new color factory. It will give you these ones, right? Do we really need this? Can't I just get the factories directly from here?
I think yes, you can. You can just remove this class.
Yeah, absolutely, right?
Right.
Yeah. Now, will there be any problem from an extension perspective or flexibility perspective?
No, I don't think there's any problem.
So what exactly is the benefit, or why these guys have introduced this class? What kind of benefit they're getting here, man?
To have the same methods, Doctor, on all factories, shape factory and color factory.
Polymorphism.
Yeah, polymorphisms. They're trying to enforce polymorphism here. But again, as you guys have pointed out, and it's actually a spot on, and I'm very actually happy that since if it's going to violate the solid principles, then the question is what exactly they are trying to achieve here, right? If it's going to be beneficial for them, for achieving a better structure for their design pattern, then probably you can have it. Otherwise, to be honest, you can actually merge these two together, and you can actually create factories from this factory producer itself. And as a result, you can get rid of the violation of your solid principles, right? So as I said, this is just an example, to be honest, and it's not probably a perfect example, but the reason I picked this one here is because it just helps us visualize in an easier way what exactly the concept of an abstract factory is. Okay, so basically, yeah, I mean, I agree. Probably you can get rid of this one as well. I mean, you can do these two things together in one go as well, if you really want to.
But even, Doctor, if we remove the abstract factory, if we want to add a new factory, we need to modify the factory producer first. And this will violate also the open close principle.
Okay, now the open close principle, see, the open close principle does, was what? Open for extension, closed for
modification.
changes, right? So, yes, so basically, you know, the idea here is that if now the moment you're going to have a change here, you got to be able to somehow, you know, for sure you will have still some change there, right? Now, if I add a new factor here, let's say, let's create a new factor here, right? So let's say, what would be a good example here, guys? Color, shape, what could be it? Whatever, X, Y, Z, right? So if I add that one here, where is this one? So if I add that one here, what kind of changes I will have to do here? If I add a new one.
Just add another else if statement.
You will have to add another if statement, right?
Right.
Now, if you're going to add another if statement, will it violate the open and close principle?
I think yes.
Yes.
It will.
What was the open and close principle?
I think it will violate it if there is a method, but you just modify a method here.
Yeah, so we're basically modifying a method here, right?
You're not violating it.
Yes, exactly. Because it doesn't mean, like, for example, open and close principle does not mean that you cannot, you know, update something at all. Otherwise, that will be nightmare. It will never happen, right?
Right.
Got the point?
Yes, got it now.
Yeah. So, but yeah, this is absolutely true that here we have an implementation. Basically, it's not doing anything. It's just not doing the get shape thing. All right. So probably, as you guys have pointed out, you know, if you do it directly, you still, if you basically you merge these things together, you know, you can still live with it. And now let's look at the demo class and see what's happening here. Take a moment to see what exactly you're doing here. So basically, you're doing what? First of all, you're getting a factory, right? So you're getting your shape factory, and then now you are creating objects. So you say, I want a circle object. So basically, you get a circle object. If you're looking for a rectangle, you will get a rectangle object, and so on and so forth. Similarly, if you're looking for different kind of colors, so you're basically looking for a red color, you will use this color factory to get an object of red color and an object of green color, and so on and so forth. Do you realize the strength of this pattern? Of course, as I said, these patterns will introduce more complexity into the structure. They will introduce more piece of code. But what's the real benefit here? What's the real benefit here?
Flexibility.
Yeah, flexibility that, you know, if you make changes somewhere here down the track, right? You don't have to really know these things. Anything else?
Doctor?
Go ahead, please.
We have reduced coupling in the relationships, I think.
Exactly. We have reduced coupling. So basically, rather than this demo class being tightly coupled to the rectangle and square and then circle and red and green and blue and creating their objects here, now basically you have completely decoupled it. You only need to worry about this factory producer and that's it. And from here you get the factories and khalas, that's it. You create objects. Remember, still it's a creational design pattern, right? So you're still interested in creating objects. This part is what is the abstract factory, that you're getting an object, or you're getting an object, or you're getting an object, and so on and so forth.
Doctor, can I ask a question?
Yeah, go ahead, please.
For the open-closed principle, the
Yes,
example
please.
we took in that class was very similar to the example of the if statements in the this one. What makes it different? I think it's very similar to the example we took before. So what
Okay,
makes it
so let's do this. Let me, since we talk about it, it's very important for us to look at it. So let me see if I can open that one here, right? Let me open that one and share it. Can I share it again? No, it's not allowing me, so I might have to do this way. Can you see, guys, this one?
Yes, we can see it.
Okay. So what exactly we were doing here? We had a book discount, and we have the discount manager, right? And then we follow the single responsibility. We said that, you know, every class is doing what. Then we change the get the biography discount, and what else we did? We had a discount managers. We had these two ones coming in, and we said that have we violated this one, right? How we violated the open close principle here?
we're creating new methods if we are adding new discounts for other types.
Yes, we're creating new methods here, right?
Yes.
While in the example we just had a look, were we creating new methods?
No.
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 Just modifying.
Just modifying. So basically here the point is we violate the open close principle, and see what was the solution here. What kind of solution we created? Look at this. What we did, we had a cook book discount, and we created a biography discount, right? So that they are completely different. And eventually, you know, we called it process book discount. And I think, do we have that UML example? I don't have a UML code for this one. Strange. Okay, doesn't matter. But I think you got the point. I think so, right?
Yes.
Right.
So
So it's not.
only.
Yeah, go ahead, please.
So modifications to a method is allowed, and it's not breaking the open-closed principle.
Yeah, within a method. Within a method.
Okay.
Yeah, the implementation, for example, say, for example, here, for example, you have a get book discount, right?
Right.
So tomorrow, if you make it 70%, it doesn't mean you have violated the open close principle.
Okay. I understand.
Yes, it's a good.
Thank you.
Yeah, I think it's a good point you raised, alhamdulillah. So come back and have a look. So let me close these ones and come back to the one we were talking about. Abstract factory. Discard these changes, and okay. Let me share that again now. Are you able to see the screen again? Are you guys able to see the screen?
Yes.
Okay, thank you. Okay, so basically we were kind of, you know, we now, I think I'm very confident. I think so. I get a feel now that you're comfortable with singleton and factory and abstract factory as a concept. Now let's look at another very interesting one, which is called prototype, and it also allows us to create these objects, but slightly different from the three design patterns we have gone through so far. So what this one does, This prototype, basically, the design pattern is all about creating duplicate objects while keeping performance in mind. So in other words, rather than using the keyword new all the time to create a new object, we will be rather trying to create a duplicates of these ones and kind of clone them, right? So the whole idea is that rather than all the time you have to go on, like was happening in the singleton but in the singleton, of course, you only create one, but in the factory or abstract factories, you were creating every time a new object. So new circle, new red color, new rectangle, so on and so forth. But sometimes creating a completely new object will be very much costly for you in your performance perspective because it incurs cost. And if these objects are always going to be of the same type, why not just create a clone of the current object? And this is the whole focus of this design pattern, which is called the prototype design pattern. This pattern basically, is used when creation of object directly is a costly exercise. For example, and this is just one example, and we can think of many other examples as we discuss. For example, an object is to be created after a costly database operation. So what we can do is we can cache the object, returns its clone on the next request, and update the database as and when needed, thus reducing the database calls. Or let me give you an easier example. Let's say you're creating a Subway, you're creating a game called Subway Surfer, right? I'm pretty sure you guys have played Subway Surfer, correct? Yeah,
All of us.
all of us probably, yes. So see, when you play Subway Surfer and the object, the actor, the character is running, you see the trains, right? And they are the same, similar trains, right? Or you have the coins, right? So what's the point of creating every time a new coin? Because that's going to be a cost in a sense, right? From a memory perspective. And so on and so forth, and from an actual execution perspective. So basically, you can go on and make copies of that using the concept of clones. Anybody has used the clonable clone concept in the Java programming?
Yes, Doctor, we have.
Yes. And what exactly
All
it
of
does?
us.
All of us, right? What exactly it does?
It retains a copy from the object
Yes.
that have the same attributes, but not the same address.
Exactly. So that's the same idea here. The prototype is exactly doing the same thing. This is exactly the whole idea behind this design pattern. That rather than creating all the time a new object, just create a clone of it, right? So the key concept here is that when you're designing for multiple instances which are the same in certain key attributes, well, what's the point of all the time creating a new object? Why not I just go on and make a clone of it? Now, when you guys were doing your, I think probably in your ICS 201 or 202 when you did clones.
201, Doctor.
201, right? What was the example where you guys did it?
Well, Doctor, it was a long time.
Long time ago, right? Anybody remembers?
I think it was with polymorphism. With polymorphism and abstraction, I think you have multiple types in one array, and then you clone based on the type. But I'm not sure.
Yeah, something like this. Something like this. Basically, the whole idea is that if you're going to have the same instances, well, what's the point of creating them all the time? Just create a clone of them, right? And this is whole idea behind the prototype design pattern. And see, still remember, we are in the creational design patterns, right? We're still in the creational design patterns. So these all patterns allows us to create objects. So the prototype is different from these ones because it says, oh, well, if you are gonna have a similar, kind of objects you need, well, just clone them. So let's look at an example here. Let's see what's happening here. So again, we're going to stick to our circles and rectangles and squares example because it's a bit easier for us to understand. So basically what we're doing, we're saying a shape and it has a certain attributes. and you can have some getters and setters, and you have something called clone. And of course, you have something called shape cache. Here you create a hash table or a hash map, and then you can go on and create a shape, and then you can load that shape to the cache. In other words, you can create an object and then load that object into the hash map. And this demo class will only be using this shape cache to go on and get copies of the objects rather than having direct connection with them and creating their objects directly. Now, by the looks of it or on a face value, how this is different from a factory one, because I mean, I can have from a structural perspective, you can say this is a factory. How this is different from factory?
I think this example, we're creating just one square and one rectangle and one circle, and then we copy them.
Jazakumullah khair. Spot on. I think I'm very confident now. This exactly it is. So because it's creational, we're still interested in creating, but here we are only going to create once, load into the cache, which in our case happens to be a hash map. And then next time, anytime this demo class wants an object of a certain type, like a circle, we'll just go to the map, hash map, and grab it for it. Make a copy of it. So let's look at the, let's look at the code. And I'll come back to the previous two slides, inshallah. So basically, what's happening here? So we're creating a shape class, of course, which is doing implement clonable. And this is how you're able to do clones, right? We have a abstract void draw method, which is basically, just going to help us draw, but we don't care about that at the moment. We have some setters and getters, right? So this is going to help us set an ID. This is going to help us get an ID of that object and type of it. And what's happening here?
Here he's cloning, I think. He's making the clone here.
Yes, exactly. And next, if we look at these, because it's just an abstract class, so these ones will go on and extend these rectangles, squares, and circles. And in this case, they will just go on and override or do a polymorphism for draw. But let's look at this class now, what exactly it will do. Take a moment. So what's happening here? First of all, we're doing what?
We are creating the card.
Yeah, so we're creating this hash table or something called share map, right?
Yes.
Now, what's happening in this part?
We are creating the first
shape.
No, I don't think we are creating the first shape. We are creating the cloned shapes.
Yes, so we're creating the clone shapes. So we're getting the shapes, right?
Yeah.
And where we are creating where we are actually adding them to the hash table, we're adding them here in the load circle, load cache. So basically, you create a new circle and you set its ID and you put this into the hash map. So you create a circle object, call it 1 because you need a reference in your hash table, right? And index it and insert it. Next time you create an object of square, insert it. Object of rectangle, insert into the shape map, right? And if you want to get a shape, here you will be saying, okay, give me a shape ID, right? So if you're looking for a shape ID 3, this means rectangle, you will go and create a clone of that one, okay? So far, so good?
Doctor, I have an issue.
Yes,
Who
please.
initiated the load cache?
Who is doing this? Okay.
It should be the main method.
See what's happening? Exactly. It should be the main method.
Okay, I guess Thank
All
you.
right. So first of all, he will go and do the load cache. This means the moment he will do the load cache, one object of the circle, one object of the square, and one object of the rectangle are created, and they've been indexed. Next time, every time he's interested in getting a new shape of circle, basically he will just call a get shape method, and we know what's happening in a get shape method. Give me an ID, and I'll grab you a clone of it.
Doctor,
Yes, please.
since in this application's life cycle, we're only going to have one shape cache.
Yes.
So can we make it singleton and call load cache in the private constructor?
Yeah. So if you want to enforce this behavior, huh?
Yes, if I want to enforce one shape cache,
Yes.
and I want to call load cache as soon as
Only
the
once.
program starts. Yes.
Yes. Absolutely. Why not?
Okay.
That will enforce it. Yes, that will enforce it. So here in this case, you're right. In this case, it's not a binding thing in a sense. Of course, spot on. But yes, please go
Sorry.
ahead.
Could you please repeat what that's Abdullah said?
Okay. Now he said that, for example, can I enforce this load cache when I call load cache, right? I just want to call it one time only.
Okay.
Right, because he wants to enforce behavior that only one object is created for circle, squares, and rectangles. So he
Okay.
does, yeah. So he doesn't want that, if I understand his question correctly, he says that, what if I write this piece of code again here? What will happen?
Doctor,
Yes.
I actually meant that the shape cache itself, the shape cache class itself, to be singleton.
The shape class itself to be singleton.
Yes, the shape cache, and then inside private constructor, I will call load cache so that the main method does not have to call it.
Okay. I got your point now. So basically, here you will have the constructor of the shape cache itself.
Yes, and
Yeah,
I will make like singleton, exactly
like
like
singleton. Yes.
Yes.
Did you get it now?
No, sorry.
Okay.
Could you please
So
repeat it?
basically, he's saying here, and it's a good suggestion. He's saying that, for example, in this case, what's happening? The creation of the object itself is being done through the main method, right?
Right.
So the main method is calling the load cache, right? And the suggestion here is that if this load cache whole thing, I put it into a shape cache constructor. And I make it private. So this whole load cache, like remember in the singleton, we had this get instance, right?
Right.
This whole part is part of the constructor of the shape cache. And it's private and it's singleton, so all they will be only be able to call it one time, or even if they call again and again, it will not do much.
I get it.
Sorry, I lost the voice there, to be honest. You get it?
I get it. Yeah,
Yes,
thank you.
yes. And basically, in this way, you will be actually incorporating a singleton there as well. So this in a nutshell is the whole idea behind prototype, right? And let's go back to one or two slides which we skipped, so that now it will make sense now, hopefully. So basically, the idea is that, of course, it hides the concrete product classes from the client. So basically, as we can see here, these classes are hidden from the main method. They don't really need to know this. And with that amazing suggestion, even you make a singleton, that's it. And It lets the clients work with application specific classes without modification. So basically, you don't need it because it's all segregated. It's all decoupled. You know, you can add and remove them. You can make changes into them dynamically and so on and so forth. But the main focus, to be honest, we don't really have to worry about this. The main focus is to isolate the parts of each of from each of the customer. You make them decoupled, and you basically, you know, use the clone concept to go on and create new objects rather than using the new. And the real benefit is basically from a cost perspective or a performance.
Doctor, I'm sorry, but if we are using a clone method, inside the clone method, we will use, we will call the constructor. So what's the difference exactly? Since we are use new at the end.
Fair enough, fair enough. Now let's look at this one now again. Let's see. So for example, this main method is now loading a cache, right?
Yes.
So he went on and used the new method to go on and create a circle, right?
Yes.
And similarly, he went on and create a, let me call a circle, rectangle, and square, right?
Exactly.
Now, next time he wants to get another object, right? So he wants to get another circle now. So what will happen here? He will be not using the new method anymore. He will go to the cache and get the clone of this circle, which is here. See, in next time he will call the get shape, right? In the get shape, he say, okay, what ID you're looking for? He says, I'm looking for circle. I want to create an object of circle. So he will say, okay, number one, he will go to the hash map or shape map, in this case, the hash table, and says, okay, give me a copy of number one object, which is in this case circle.
Yes.
So the first time, of course, you need to use new because you don't have any object, right?
Yes.
So the first time you're always going to use new method, but the next time you want to create another object, now you will be not using the new method again. You basically be using a copy of, you're making a copy of the object.
Yes, but doctor, what I mean is that inside the clone method itself, here you say return shape, cat shape dot clone, right?
Yes.
Inside the clone method itself, you will use, you will call the constructor.
Inside the clone?
Yes.
Oh, see, this is the whole idea, right? This is what the clonable will be doing, right? This is what the clone does. It will go, of course, it will just make a copy of it. So the concept of the clone in for example in Java basically does what? It does what? It makes you know, so whenever you use a clone method in Java, basically, you know, it allows you to make a copy of the value of an object. And that's it.
Yes, yes, nice.
All right.
But doctor,
yes, please.
sorry for interruption.
Go ahead.
But how is it cheaper? How is the clone cheaper?
Okay, now the cheaper, the cheaper point here is that, you know, when you are creating objects, and these objects, for example, needs to be done over a network, for example, right? Right. Okay. And for example, you know, let's go back to this example here, where I have it here. Let's see what's happening here. So for example, an object is to be created after a costly database operation, right? Now we can cache the object, return this clone on the next request, and update the database as and when required when reducing these database calls. Or let me think of another example why clones are better than the new ones, right? Let me think. for example, see, at the end of the day, in, for example, in the service server, for example, right? In the case of a service server, you know, you're still going to create coins, right? You still need coins. There is no doubt about it, right? But it will still be allowed a memory location. It will still be trying. It will be still be given a memory location. But the saving of the cost is in terms of you know, the especially the shallow copy of an object, right? The shallow copy of an object in a cloning method is done without calling a constructor. This is where the difference is.
Okay. Okay.
Right. And so basically, you know, you don't call a constructor again. So basically, as was a question earlier, when you call the new method, you call the constructor. And in this case, for example, the constructor will be called only once when you're creating and loading them to the cache. While you will be getting clones, you will not be calling the constructor at all. We'll be just making a copy of this one.
Okay, Doctor.
Yeah, got
Thank
it?
You. Yes, I got it. Thank you.
So yeah, performance depends on the content of the clone, of course, right? And it's a bit subjective, but the benefit here is that, you know, that here we have another possibility as a pattern where we can go on and what we call create objects, where we don't have to really go on and create absolutely a new object every time. We can use clones to without calling the constructor and make copies of them. Oops, I think we're running out of time here, right? Isn't it? Alhamdulillah, I think we're kind of done as well anyway. So we're right on the money here. Don't do this, don't do this, please, please, please. Oh, sorry. I need to go back to this one. So in a nutshell, we have something called singleton, which allows us to create exactly one object. We have something called factories, which allows us to create, you know, objects of similar group of classes. We can have abstract factory, which where we can have factories of factories or multiple factories or family of factories. And then we have something called prototype, which is kind of a mix and a match that you go on and create an object first time, load into a hash table, and next time around, don't create a new object, make a copy of it, and off you go, right? So let me stop the recording here and take an attendance. And of course, the floor is open for questions.